Have you ever seen someone weigh their coffee, adjust their water temperature, or talk about grind size? Today, we're going to discuss why those variables matter using the Chemex as an example. Now, one of the first variables I want to look at when using the Chemex is the filter paper itself. These filter papers are oxygen bleached and completely compostable, but they are 5 grams. This means there's a lot of paper, and as a result, a lot of papery notes that we don't want ending up in our coffee. The first thing I'm going to do is place this filter paper in the Chemex. What you're going to want to do is the thicker side with these 3 folds. You want to stick that towards the stem so we prevent that from sinking in and creating an airlock. Next, I'm going to use my kettle and rinse that filter paper. You want quite a good rinse, again, in order to prevent that papery taste from ending up in our cup. Now, after I've thoroughly rinsed that filter paper, I want to dump that water out. We do not want that in our coffee. And now we need to start thinking about grind size. So how do we measure grind size? Well, typically we use a value called a micrometer, which is often shortened to the term micron. Now, why would we do something as absurd as weigh out our coffee? Well, there's a few reasons for this, but the simplest reasons are we want to make sure that we're not using too little or too much coffee and that each cup is consistent. So what I'll do is I'll get a container, I'll place it on a scale, I'll then tare that scale. Next, I'll open up a bag of my favorite whole bean coffee, and I will weigh out however much I'm going to use for this cup. In this case, I'm going to use 20 grams. Because I know I'm using 20 grams of coffee, now I need to figure out how much water am I going to use for this 20 grams of coffee. We typically achieve this using ratios. This is very, very simple, and the math isn't very difficult. And trust me, I'm a former infantry guy, and I'm not very good at math. So what we end up doing here is taking 20 grams of coffee, and we're going to multiply that by 15. That will give us the amount of water we're going to end up using. What is 20 times 15? 300. Wow, that's a big number. We're going to use 300 grams or milliliters of water. Next, we need to talk about grind size. And the easiest way to think about this is the coarser we go with our grind size, the faster water flows through that bed of coffee. The finer we go with our grind size, the slower water will flow through that bed of coffee. What does this mean? Well, the finer coffee is, the easier it is to extract. A good way to think about this is maybe the more intense or the more strength or concentration will end up in that cup. If we go a bit coarser, now we've got a cup that might be a little bit weaker. You can adjust this to fit your individual preferences. So for this Chemex, what I'm gonna do is set the fellow opus to about 8, get my coffee and put that directly into the grinder. I can then press grind. Now that we've got our coffee ground, what I'm gonna do is put our Chemex on top of the scale and then tare once more. I'll then take the collection tray out of the opus and put that coffee directly into the Chemex. This is just so we can double check to make sure that the amount of coffee that we weighed ends up in our Chemex. Finally, we need to start thinking about water temperature. And this is pretty similar to grind size in that the hotter our water temperature is, the quicker coffee extracts. The cooler our water temperature, the slower the coffee will extract. So if we're thinking in terms of how strong do we want that coffee to taste, what is the concentration of that cup, maybe go a little bit hotter with your water temperature if you want something a little bit stronger. Or maybe you have a light roast coffee, well, we can go a little bit hotter with our water in order to extract that coffee a little more easily. Now, if we have something a little bit darker, it might be better to go with a lower water temperature. Again, we're not trying to work as hard to get those solubles and pass them through our filter into our cup. So now that our water is heated, what I'm going to do is pour that directly onto our bed. What I'm going to do first is called a bloom. I'm going to put a smaller amount of water, typically about 3 times the amount of coffee I initially put in here in water. So if I had 20 grams of ground coffee in here, I would add 60 mils of water for my bloom. This will allow CO2 to escape. That way I'm not trying to add water as another reaction is occurring. I'll typically wait about 30 to 45 seconds, and after that, I can move on with the rest of my pour. You'll also notice that I used a gooseneck kettle. This just makes it a bit easier to control my stream, something that you might have always struggled with. Now, you've heard me say the word extraction quite a bit. And all this means is we're thinking about coffee as a solution, with water as a solvent and coffee as a solute. What we're trying to do is dissolve any dissolvable solids that are in coffee, pass them through a filter, and put them into our cup of coffee. That's what we're tasting. 300 mils in, and I'll do a small swirl. This just keeps coffee from hanging up on those sidewalls. We get a nice flat bed at the end, letting us know that all the available coffee in this filter was being included in our slurry. So before we move on to the next segment, don't forget to like and subscribe. This will just make sure you don't miss any future content from Coffee or Die. So let's cover why we did the things that we did to make this cup. So we started out, the silencer's moved, and this is a lighter roast. So because of that, we made a few decisions. We decided right off the bat we were going to do a 1:15 ratio, a bit less water to the parts of coffee. So 1:15 as opposed to maybe a 1:16 or 1:17 that we would use with other conical drippers. We also went with a hotter water temperature. I used 205°F water. Again, we know that this is a bit lighter, so it's a bit harder to extract what's available in that coffee, pass it through a filter, and get it into our cup. Our grind size, we went with a medium grind. We know that the Chemex filter papers are pretty thick, and because of this, our drawdowns are also pretty slow. We don't want to go so coarse that our cup ends up tasting too weak, but we do want to make sure that the drawdown period isn't too long. As a final result, we've got a cup that is probably pretty fantastic, but the only way to know for sure is to taste it. Pull this filter paper out, toss that, and we're ready to pour. I will even go an extra step and see what my yield was. So we used 300 mils of water to make this cup, but how much actually ended up coming out? And we have exactly 260 mils. Now, this will be a video for the future, but when we take numbers like this, we can actually figure out how much coffee ended up in our cup. This gets into TDS and extraction yield percentages, but of course, we want to wait to get that deep into the woods. What is TDS? Well, TDS stands for total dissolved solid, and typically we use a refractometer to test that value. So how did this cup end up tasting? Really nice. We've got a good body, great acidity, and a little bit of citrus paired with some of the chocolatier notes associated with this cup. And I can make this consistently each and every time by following something as simple as understanding my grind size, my ratios, and my water temperatures. So now I don't have to worry in the future about will this next cup be as good as the last one. I have everything dialed in and know I can make this cup great every time. Now, one way I like to check these bags, give them a good slap and a good tickle. That's fucking stupid.